We are going to continue with the probability. And with the probability, we are now at mutually exclusive events. Mutually exclusive events. Any two events that cannot occur at the same time is called mutually exclusive events. So you can think of, let's say when you toss a die, okay, and you want to obtain 1, or you want to obtain 5. You see, it's one die, so there's no way that you can obtain 5 and 1 at the same time. It can never happen that way. You either get 5 or 1. But there's no way that you can get it at the same time. That's what we call mutually exclusive event. So let's have the definition here. Is that okay? So any event that cannot occur at the same time is said to be mutually exclusive event. So I gave you simple explanation to that. Like when you are tossing a die and you want to get, or even a coin, and you want a head and a tail, you can't get it at the same time. You either get head or a tail. There's no way that one coin and that when you toss it, then you get head and a tail. No, it doesn't work like that. So that's what we mean by mutually exclusive event. It happens once at a time. So now, because there's no way that you can get 2 at the same time, it means that the intersection here does not work. Already I've explained what the intersection means. The intersection is the multiplication and the union is the addition, or you can say or, then the multiplication is and. Take note of that. So, why am I saying the intersection does not work here? You see, when I toss a coin, the sample space will be, a die, the sample space will be 1, 2, 3, 4, 5, 6. Is that okay? So, looking at this, event of obtaining 1 is 1. There's no way that I can obtain 1 and 2 at the same time. You see that? Event of obtaining, let's say, 3 is also 1. We can get 3 only once. Is that okay? So, because we toss the die once, is that okay? So, there's no way that we can get 1 and 2 at the same time. No. So, we can have probability of getting 1 or 2. Either you can get 1 or 2, but you can't get 1 and 2. So you have to understand these two English. So due to that, we have established that and is the same as multiplication, and in broader distance is the same as what? Intersection. Is that okay? The same as intersection. And we also said that or is the same as addition, is the same as union. If that is the case, since we cannot get and, like we cannot get 1 and 2 at the same time, then we can say that probability of A intersection probability of B, which is the same as probability of A intersection B, is equals to 0. Is that okay? So probability of A intersection B is equals to 0. It does not exist. It's not there. It can never happen. Is that okay? But probability of A union probability of B. When you see union means what? Or. Is that okay? And this one can be written as probability of A plus probability of what? B. We can get A or we can get B. when you toss the die, you can either get 1, or you can get 2, or you can get 3, but you cannot get 1 and 2 at the same time. It doesn't work like that. So that's why the intersection is 0. But for the union, it works. This is called probability rule of addition. So when we have something like the probability of A plus probability of B is called probability rule of what? Addition. For the intersection, it's 0. I hope it's okay. I hope you understand, because there's no way that you are going to get intersection. In any case, if you are tossing 2 dice, that one, it can be possible. Like when I toss 2 dice at once, I can get 1 at the same time. That one, it can work. But when you toss it only once, it's mutually exclusive. The numbers, you can get them 1 at a time. That's what. So we are going to look at our first example. So the first example is write down the sample space for the set of the first 10 positive integers. That's I. What is the probability of selecting either 1 or 10? Either 1 or 10. So this is the first example you are going to do. So solution. First one, the question is saying that you should write the first 10 positive integers. So you know that integers are both positive and negative whole numbers, but you want the first 10 positive integers. So let's write our sample space. That will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the first 10 positive integers. Is that okay? Now, if these are our first 10 positive integers, what do you want? The question is that you should find probability of obtaining 1 or 10. So here, our sample space, if you count them, you get 10, right? First, you have to get the event of obtaining 1. It's 1. Because you can only obtain 1 only once. Then the event of obtaining 10 is also 1. You can only obtain 10 only once. Is that okay? You can only obtain them only once. So now, first, let's find probability of obtaining 1. That's number of events obtaining 1 over the number of sample space. So probability of obtaining 1 is equals to 1 over 10. We also look for probability of obtaining 10. Probability of obtaining 10 is number of events of obtaining 10 over the number of what? Sample space. So obtaining 10 is 1 over 10. Please don't be confused so that you go and write 10 over 10. It's wrong. You can only get 10 only once. Is that okay? Take note of that. Some people, because they saw me writing 1, and here is 1, they'll be tempted to do so here. So by the law, the question is that you should find probability of obtaining 1 or 10. And that one, the formula, because it's all is the same as union. Is that okay? So the formula is going to be probability of obtaining 1 plus probability of obtaining 10. And probability of obtaining 1, I have 1 over 10 plus probability of obtaining 10 is also 1 over 10. And this will give us 2 over 10. Is that okay? 2 over 10 is the same as 1 over 5. So that is the solution to this question. Is that okay? Now let's look at the second example. So this is the second example. In a football match, probability of Kotoko scoring a goal is 0.25, and the probability of her scoring is 0.4. It means that the chance of her scoring is higher than that of Kotoko. What is the probability of Kotoko or her scoring? Is that okay? So here in this question, They are giving us probability. So let's E of K, that's Kotoko, denotes Kotoko, okay? Kotoko. And P of H also denotes hearts. So in this case, first one, let's look for probability of Kotoko scoring. So it was given as 0.25, and probability of heart scoring is 0.41. But the question says, what is the probability of Kotoko or heart scoring? So probability of Kotoko or heart scoring is going to probability of Kotoko plus probability of what? Hearts. Probability of Kotoko is 0.25 plus probability of hearts 0.41. So we add them. This is going to give us 6, right? 0.66. So that is the answer to this example. So this is very simple work. Okay, so this is the last example. Then I'll give you one to try. Make sure you subscribe. Then also leave a comment. So the first example is, given that X and Y are mutually exclusive events such that P of X equals 0.5 and P of Y equals N, P of Y equals N, and P of X or Y equals 0.8. Find the value of N. So the question is saying that they are mutually exclusive. They are giving us P of X to be 0.5, P of Y to be N, then P of X or Y to be 0.8. The P means probability of X, okay? So with this, you know that the formula for X or Y is going to be P of X plus P of Y. But P of X or Y has been given as 0.8 equals P of X, which is 0.5 plus N. So in this case, I will bring this one here. I have 0.8 minus 0.5 equals N. Now 0.8 minus 0.5 give us 0.3 equals N. Therefore, N is equal to 0.3. Same, isn't it? Please subscribe. I will give you a question to solve. You can leave the answer in the comment section.